Hello, welcome to ANS Solver. This is the fifth question of the paper. So they have given us a random variable x, which is given in binomial distribution. So we need to convert this to Poisson distribution, and we need to calculate the probability for this. So I know this is n, comma p, correct? Because it's binomial. And I know lambda in the Poisson distribution is n into p. So I can simply do 300 into 0.01. Okay, when I do this on the calci, I simply get my answer as 3. So I can say my lambda is simply 3. Now I need the probability for this. So see, x needs to be strictly more than 2. So we need the probability of x equals to 3 plus the probability of x equals to 4 plus the probability of x equals to 5. But it should be less than 6. That's why we won't include 6. Now the formula we know for Poisson is simply e raised to minus lambda into lambda raised to x over x factorial. Now what we can do is, we can write this as e raised to minus, I know my lambda is 3, into 3 raised to 3 over 3 factorial plus e raised to minus 3 into 3 raised to 4 over 4 factorial plus e raised to minus 3 into 3 raised to 5 over 5 factorial. Now if you see, writing all of this would be a little tasking on the calci. So what you can do is a simple way to write on the calci. You can write this as, okay, click on shift and then click on log. Okay, when you click on that, you'll get this as, you'll get a summation sign with a limit here, and a bracket here. Now if you see, you're basically calculating the summation from 3 to 5 inclusive. So write 3 here, write 5 here, and write e raised to minus 3 into 3 raised to x or x factorial. X will basically take all the values between 3 to 5 inclusive, and to write an x you need to click on alpha and the closing bracket sign. Got it? So you can simply click on that. You can write this on the calci. Okay, it will save, if not for this question, for the other questions it will save a lot of time. Now when I click on equal to, I get my answer as 0.493, which is basically the final answer of the question. So basically you need to write all your steps till here, and then after that you can solve this on the calci to save time. Now the random variable y has a distribution Poisson with lambda, where p of y equals to 0 is equal to p of y equals to 2. Now we know the formula is e raised to minus lambda into lambda raised to x over x factorial. So now I simply have p of y equals to 0, which is equal to p of y equals to 2. So I can basically write this as e raised to minus lambda into lambda raised to 0 over 0 factorial, which is equal to e raised to minus lambda into lambda raised to 2 over 2 factorial. So this is basically e raised to minus lambda, because lambda raised to 0 is 1 and even 0 factorial is 1, equals to e raised to minus lambda into lambda square over 2 factorial. I can simply cut this and I can write this as lambda square equals to 2 factorial, which is 2. So I get my lambda basically as root 2, which is the final answer of part 2. Got it? And obviously I know whenever we write root it should be plus or minus, but lambda can only be positive, so we write positive. Now the random variable z has a distribution Poisson of 5.2, and it is given that, and they have given us an inequality. Okay, so we know the formula again, which is e raised to minus lambda into lambda raised to x over x factorial. So now I can basically write this as p of z equals to n, which is less than p of z equals to n plus 1. Correct? So now using this formula, I can write this as e raised to minus, my lambda I know is 5.2. So e raised to minus 5.2 into 5.2 raised to n over n factorial is less than e raised to minus 5.2 into 5.2 raised to n plus 1 over n plus 1 factorial. So now I come to my B part. So I'll just write the question again, like the equation we obtained in part A. Okay. So this is what we have, which is less than e raised to minus 5.2 into 5.2 raised to n plus 1 over n plus 1 factorial. Now, the first thing I can do is I can cancel both of this, correct? Now, use your indices here. I know that a raised to b plus c can be written as a raised to b into a raised to c, correct? So I can basically write this as 5.2 raised to n over n factorial, which is less than 5.2 raised to n into 5.2 over, now see, you need to know, let's say, okay, this is an example, my n is 5, so I can write this as 5 factorial, but 5 plus 1 n plus 1 factorial is basically 5 plus 1 factorial. Agreed? If my n is 5, okay, it's just an assumption. How I know 5 plus 1 is 6, so I can write this as 6 factorial. 6 factorial is basically 6 into 5 into 4 into 3 into 2 into 1. This can also be written as 6 into 5 factorial. Agreed? Correct? In the same way, now come back to the question. I can write this as n plus 1 into n factorial. Correct? That's what? Now, I can cancel this on both sides. I can cancel this on both sides. So I'm left with, and I can take this up here to get n plus 1, which is less than 5.2. So I can write this as n less than 5.2 minus 1, which gives me my n is less than 4.2. So the maximum value for n, the largest possible value for n, is simply 4. Correct? Because n can't exceed 4.2. That's why.